Evan here. Actually just got back from the mailbox and my Azteeg X3 Pro came in. I was kind of waiting on it for a while. I think I ordered it 2 weeks ago and it was in stock, so it took a little while to get here. I was upset about that and I can forget about it now. So I don't normally really care for unboxing videos, but I'm gonna give it a shot. The timing just worked out perfectly for an afternoon nap for the kids. So I'm going to go ahead and get this knocked out while I can. I was going to open it anyway, and I thought, I'll set up the camera and give it a shot. So here we go. This is from PANUCAT Devices. So we'll see what we got in here. I hope that's what this is, actually. There we go. That was easy enough. Stat bags. So this is a some assembly required sort of board, so we'll leave all the accessories and everything aside for the moment. Get this going here. There she is. She comes with fuses and everything. See if that stays in focus. Smells electronic-y, to be expected. Got a lot of LEDs here. That's kind of cool. Guess you can use those for status. I'm not sure what they're mapped to just yet. Power input, micro ST USB female for host PC communication, and that's not something I was expecting actually. All of these connectors are pre-soldered. Who'd have thought? I read in the description that you have to solder these on, so maybe they have modified their build process to make those, which is pretty awesome actually. I already got my soldering iron set up. I was going to do some videos on putting those in, but now I don't have to, so that's cool because that means you wouldn't have to either, hopefully. They should probably update their description on that so that people don't prepare to solder all those on. You do get your choice of connectors when you buy one of these, and I went for the screw terms. You can get the plug-in type, either straight down or right angle, and I thought screw term was fine. They're actually a lot smaller than I thought they would be. The board's about the same size that I expected, so I'm kind of test fitted in here. It may go down in here. It's not really going to fit there, but I didn't really expect it to, so that's good. There's that, see the Atmel 328p, or no, sorry, this is a 2560. I think I mentioned before that it was a 328p, but this is a 2560. That's the mega one, I believe. Anyway, that's it. I'm going to see what else we got in here. Be gentle with my board. Oh, I hope they gave me some thermal tape, and it looks like they did. Okay, so open one package of these guys. Went ahead and got this with the Sure Steppers from PANUCAT Devices as well, Sure Stepper drivers. Something I liked about these, I'll do a close-up on them here in just a minute actually, but what I like about them is that the actual driver chip is on the bottom down here. And it seems really logical to me because I actually have looked at these in the past before I got into this 3D printer stuff. And there's a thermal pad on the bottom of them. I'll wait till I get closer in to really show it, but the heatsink really belongs on the bottom, on the thermal pad that gets soldered to the board. So that's what they've done. They flipped everything over from the traditional version of these kind of broken out chips, and it seems like a good idea since I'm going to be running them pretty much flat out at 2.5 amps. That's pretty important to me that I have good cooling, so I'll put an active fan on them as well and hopefully get them in an enclosure at some point. But early on I can always limit the current. This board does actually do digital potentiometer current limiting from firmware, which is pretty cool too. So I'll probably just run it flat out, but if I was really using the current limiting, that would be a pretty important thing for me. So I mean, it's pretty cool. I got 8 of these bad boys. It was only like $5 extra to get 8 than it was to get 5. So really all I'm going to use right away is 5. But the extra 3, they're about $12 each. So I got the extra 3 for like $5. So they came out to like $2 or $3 each with the deal. Hope that deal stays around. And I've got 1, 2, 3, 4, 5, 6, 7, 8 baby little heat sinks with heat tape on them. Here are my thermocouples. I threw those in really because I don't want to have to make a DigiKey order if I break one or something like that. So they were just a couple bucks to add on. And a couple of limit switch style things. I've got a few of these kind of scraps laying around. Those don't click nice. Oh, there we go. So a lot of jumpers and ooh, another heatsink. I'm not exactly sure what that's for, but I will probably find out. So that's it for the unboxing pretty much. I'm going to get a close-up of a few of these things, popping the driver's boards in. Okay, so we got the Azteeg board here, a little bit closer in. Starting out here, we have HE 1, 2, 3, 4, 5, 6, 7, 8. And so that is basically for a bunch of hot ends, up to, I don't think the firmware would do it, but up to 8 hot ends. They're just transistor drives basically, from what I can tell. So you've got the ability to run some lighting off of them, a lot of LED stuff people are doing now to kind of show status or to just kind of put bling on their machine basically. You can run some fans, so PWM speed controlled fans on those guys. You can see in the diagram, you've got hot ends here. This is actually the wiring diagram that they just put up a day or two. I've kind of been hounding the guy to put them up, and he hasn't been super responsive, but it's good to see that they're up and available now. So maybe it'd be better to walk through this part of it first. You got hot ends down here. The fan, like I mentioned, the LED strips, another hot end if you want to go for 5 or 8 hot ends. You can do whatever. I think that's probably pretty insane, but that's the whole idea behind this board. Is it's the pro board, you know, the crazy board, but it wasn't terribly much more expensive than the regular Azteeg, which is also, I thought, kind of a more advanced board. It has more options and stuff than the typical ramps boards do. Not a lot more, but a little more flexibility. And then this came out and I was like, well, okay, I gotta get the good one, the really best one. So supports up to 6 end stops, which is pretty typical as far as I know. This one actually has thermocouple amps built in here, so it will do a few thermocouples. That's over here on the board. Right off the bottom. A lot of thermistors, up to 6 thermistors. So that's just an analog input, so that's not quite as crazy as the thermocouple inputs because they actually need an amplifier. So I probably won't use them, but it's kind of cool to know it's got them available if I decide thermocouple is a better way to go. I did a tiny bit of research into thermocouples versus RTDs, and I think you can get some more accuracy out of thermocouples, but I could be wrong on that. But it's just another option to go with. So back to the schematic, the USB port, the micro SD card. It's got a little beeper on it. Here's a little beeper, this little surface mount buzzer. It's kind of cool. Of course, the main brain chip right there. It's a 2560. I was quite surprised actually. I hadn't really seen a pin out of this, but you do still have, even with all this stuff broken out, you still got expansion 1, expansion 2, expansion 3, expansion 4, and 5 somewhere around here I saw. So it's got quite a bit of extra I/O, which is kind of cool because I was considering using this actual board as a robot controller at some point. You know, popping it out of the CNC and making a little like a RC style robot, or something stepper based. And it's good to know that I've got some extra sensors available if I want that. Hobby servos you can drive off of these things, so that's really good to have that extra expansion broken out into headers. Back to the schematic here. Here's your steppers up at the top. Boom. X, Y, Z, extruder 1 through 5. One of these will be an actual extruder for me, maybe up to 2 extruders. I don't think I'll ever go over 2. I don't really see the point. Then I will have a second Z motor. That'll take up another one of these. And then I'll really just have 2 spares. So I do have the drives for those, which is kind of cool. I might do something rotary, or I was kind of thinking if I don't go second extruder, I can maybe run, I've got the Bowden tube set up already, so I could put another hot end on a little Delta bot and run the same control board. I mean, I highly doubt I would really run them both at the same time off the same board. That's pretty crazy, but I guess technically you could, maybe, I don't know. Anyway, that way I could run 2 bots off of 1 control board, because this was kind of a bigger part of the expenditure here. I don't want to quote prices, but I think it's really relevant since this is kind of a budget thing. This was $135 for the board. The Pro one that's got 2 less stepper slots and a few less of this other stuff on the front is like $95. But those prices may change, so at the moment that's what I got this one for. It's $135 plus shipping. These steppers brought the total cost of everything I have here up to a smidgen over $200 US. So it's a pretty pricey board. I think probably some of the Ramps guys are laughing at that because you can get an Arduino for pretty cheap, and you know, you throw a Ramps board on there for like $40, but really, I mean, with these drivers, you can't really get these less than about $10 that I'm aware of, especially not these real nice ones. So I'm gonna jump right in here. I think that's, oh, actually, let me finish this over here. You got some of the pinouts here, some additional stuff there, 3.3 volts. So it's got a regulator on board for 3.3 volt, and I assume one for 5 volt, although I haven't found it on the board, but it's got to get 5 volts somewhere, I imagine. Maybe there's a 3.3 volt logic. I think you can run them on either, actually. So there is a step down regulator on there somewhere. So it's going to take your 24, your 12 volt, knock it down to logic level, but keep it for your motors. So your motors, you know, these are just little amplifiers, sort of. So they're going to take logic. You can maybe see the pin numbers here. These two coil outputs will be running. You know, V-mote is V-motor, voltage motor plus, and so that can be 24 volts. I think these will handle like up to 42 or something. I keep misquoting the voltages, but they will handle quite a bit of power. So, or quite a bit of voltage, only 2.5 amps. But you know, if you've got 2.5 amps at 42 volts, it's a lot more power than 2.5 amps at 12 volts. So they're pretty hefty little things for such tiny little little surface mount chips. They're pretty crazy. So anyway, I actually had to look up a YouTube video because it doesn't show you in here how they orient the chips in here. So I was a little surprised that they don't have that. If you look at the older version here, they show some stepper drivers in there, but it's not the stepper drivers that they sell. So I'm a little confused on that, or why they wouldn't plop this guy into the diagram. There is a data sheet for this. It's a SD8825, I believe. And it probably will show you the orientation, but I found this YouTube video where guys are running the same thing, and I matched up these three VREF pins here. It's, let's see, VREF, FLT, and DEC. I'm not sure exactly what those do. I know VREF is the voltage reference for the current limiting, so that's what that guy is. Let's see. So that's about it for that. I'm going to install this stepper driver now. Okay, so I've managed to get the little tapey tape off of here, but I left the thermal pad, so the heat transfer should be good. Just got the top side of this board. You can see some little solder dots there, through holes. They're vias in the board. And I'm just going to jam this guy right on top of those vias, so as close to the little potentiometer as possible. And of course, making sure that I'm not grounding out any of these other pins. Give it some pressure, set it down. A little more pressure, of course not too much. And that's an installed heatsink. So I'm going to stick him in the board on the x-axis here. And goes right in there. Now I can feel good about giving him a little more pressure. Just make sure it gets on there good, doesn't fall off. Actually was thinking it should go the other way, but doesn't seem to be room for it, I don't think. Are these square? Let's find out. Yeah, so they're going to short out if you go this way. My airflow is going to go that way, but hopefully it'll be alright. Otherwise I'd be shorting out all these pins. They did give me this really long heat sink, but I'm not sure exactly where that goes. Maybe, I don't know. I'm not real sure. Maybe across these. I would imagine that's what these are. These are probably surface mount transistors, so I'll need to install that heatsink as well before I do anything. But since I don't really have a lot of documentation on this board just yet, I'm going to assume that goes there. It seems about right. Yeah, that probably goes there. So anyway, kind of cross the airflow will be probably going across here. Maybe I can work on a design where I have a couple of fans on this side blowing that way. So we'll see how it goes. I'll worry about designing a box once I have a 3D printer that works. So I realized earlier when I put the stepper driver in that I forgot to set the micro stepping. So the micro stepping, if if you look here, this table for the SD8825 will show you a single step or half step, quarter step, eighth step, 16, 32nd step. What that means in very short, kind of quick words, what that means is when it gets a step or direction pulse, how far does it go? So a normal stepper motor like this, it's a NEMA 17, each click, you can actually feel the little clicks as you're spinning it. Each click on this one is a 1.8 degree per step. Some of them will be, I believe, 0.9 degree per step, and probably some other variations in there as well. So when you get this guy going one step, single stepping, you'll have to step it, I forget, 200 steps to go an entire revolution. So that'll equate to 200 steps. Now, what it'll do, the controller inside it can do what they call micro-stepping. So micro-stepping basically is a pulse width modulation between the two coils, so it can actually sit between steps. And these steps, man, they feel so tiny, but that can be quite a bit of linear distance on your rails when you're going back and forth. So, I mean, picture you've got a decently sized pulley on here or something, and it's moving the belt. So one click, you want it to be relatively small so you get nice, precise resolution out of your printer. So the micro stepping, say, let's just say half stepping, would make it 400 steps would take a revolution. And so I believe the smarts of that, actually the smarts of that are inside this little integrated circuit here. So that is the, see, this is the TI DRV 8825, which is where the 8825 comes from, of this Palau device. So they're just repackaging it onto a nice little form factor so that you don't have to worry about it being surface mount. So anyway, so I forgot to do those. I'm going to go for 30-second micro stepping. That's one of the features. Some of these guys won't do that high. 16th is about what they get normally. So I'm going to install jumpers according to this table here. So that would be MS1 is one of these jumpers, MS2, MS3, on, and I believe this just do the same thing, on, off, on. I'm going to go ahead and put all three of them on there. Come on now. Okay, all of them are installed. Note that I don't have any power to the board right now. You don't ever want to pull one of these chips while the board is powered, nor do you want to power up the microcontroller without a stepper motor connected if there is one of these in place. I've read both of those things can cause you trouble. I do like that they are modular though, so if you do happen to blow one of these up, I'll just pop one on from my spare stash here and be good to go again. Just real quick, there is some debate on all of these, which is the better way to do the heat sink, so I kind of made up my mind on this one, as well as, it's running the better chip. I think the Allegros will only do 2 amps and this will do 2.5. So if you think about it, that's a decent amount of extra overhead there, especially because my motors will handle way more, and I'm going to be putting it, like this guy's only 1.2 amps, so it doesn't really matter what one I use. But my bigger motors, here's one of them for scale. There's a NEMA 23 triple stack, 286 ounce-inch holding torque. So this guy will actually do 5.6 amps, it says right there. So it's about 4 to 5 times the motor this guy is. This one's, let's see, this one's 1.2 amp, and it's a 5. What is the units on that? 5 kilograms centimeters, I believe, of torque. So anyway, he's hooked up. I spared you me hooking these up, but they're just the 2 coils, 1A, 1B, 2A, 2B are the coil pairs. Got this colored coding right off of their wiring diagram. So I should about do it. I think I'm ready to put power onto the board. These connectors are these wires are a little bit smaller than I'm going to use in practice, because I'm going to be pushing probably 15 to 18 amps through this guy. It's fused at 20 amps, but these little speaker wires probably aren't going to do it. But for now, running one stepper, I think I'm good. I'm going to power her up. One other thing worth mentioning here, there is a power select, and it claims that by default it's set to power off of the connectors here. It says INT and USB, and so I'm going to power up off of this. I assume this is INT. the wiki on RepRap actually says that it defaults to this external connection here, but I'm not seeing that on the board. So before I apply power, I'm going to swap that over. I've got 12 volts, not yet, but I'm about to have 12 volts on these cables here. So if you want to power it up without having this external power supply to do some firmware development or download, and you don't need to spin the motors, you can just power right off a USB. So it's a good feature. Alright, I'm powered up. I got a nice pretty blue LED there. That blue is like the new green, I'm pretty sure. So, oh, and I got an LED blinking. It's labeled LED. Oh, sorry, LED3. So it's chugging along. Maybe it has some firmware on there already. I'm not sure. So I mentioned this in my first video. I've got the power supply down on the floor, and I've got it set to 12 volts right now. I'm going to be running this on 24 volts, but luckily it's a nice power supply and it can handle 20 amps up to 30 volts. So the board itself, strangely enough, handles 30 volts and 20 amps, I believe. So that's pretty cool that works out, and I'll be able to see what kind of current I'm pulling on that display on the left there, and size an actual power supply appropriately so I don't have to keep my bench power supply in here hooked to the printer at all times. Okay, so I've gone ahead and downloaded the FTDI drivers. These are linked in from the RepRap wiki site that has the Azteeg information for it. It's also got basically these instructions that I'm following now. So I've already installed that. When you plug in your device, you should see it show up as a COM port. I've got COM 10. It's a virtual port, so it really doesn't matter. These just keep going, and each time you put in a new unique device, it's going to increment your COM port. So I've just done a lot of these, which is why it's 10. So that's all good. We know what COM port it's running. So this is a Marlin firmware. I grabbed this off of GitHub just recently. You want to come in here. It's open source, which is really cool. Free to use, and it pulls from a lot of other open source projects. So I really like that. So I've opened it up in the Arduino environment, which I installed all beforehand. This is 1.0.5. You can see some information, the license, and it just gets right into the code basically. So all these different programs up here at the top are all of these programs here on disk. So you can, it's really modular code, so if you do need to make some changes, you should be able to go right to the spot you need to modify, you know, temperature stuff or LCD stuff or whatever it is you want to do. So looking in here, what we're looking for is configuration.h. Excuse me, configuration.h. This contains a lot of your main config stuff. Serial port, it's got some other serial UARTs in there that it can use, which is kind of neat if you want to talk to Raspberry Pi or some other higher level microcontroller. Over the TTL serial you can do that, which is pretty neat, and I think they break the pins out too. So if you needed something, you know, you wanted two Azteegs to run 16 steppers, maybe that would be an appropriate interface for that. We're not going to use it, we're just going to leave that alone. I think the Bluetooth stuff actually can use that serial port as well if you feel like connecting to your printer through Bluetooth for some reason. So the baud rate, that's kind of important, 250 kbaud or kbps. Moving down, this is the most important part. This is where all the pin definitions and feature definitions come from. So you can see all these different boards that this Marlin firmware runs on. Like some of them I haven't heard of. I don't know what that is. I know what Rambo is. It was the one I thought about buying instead of this, but I didn't. Some of these I think Gen 3 is a brand, which is really confusing because like Gen 7, you would think, I don't know. I'm a little confused by that, but anyway, here's the ramps boards. We're looking for this right here, 68 Azteeg X3 Pro. So it's going to define what all of our pins are for driving those step and direction pulses, and where our inputs are, how to set the direction of the pins, whether they're inputs and outputs, and which ones are analog. All that good stuff is all just in this one constant, which is pretty cool. So I'll plop that in there as motherboard. Here's the rest of this stuff. Define the number of extruders, power supply. You can have it automatically turn on your high power supply, which is kind of cool. It'll do the Xbox 360 power supply, which I guess is a real common one because it's pretty hefty. The price is right, I think. I'll have to look into that. Forget what voltage it runs. I think it's 12 volts, so I probably won't be able to use it. Moving down, temp sensors. heaters, like heated bed stuff, miniature temperature. This is cool because if your thermocouple or your RTD rather breaks loose, you don't want the thing to go into runaway and just thermal heat, because some of those, like mine's like a 230 watt that I'm going to use, and that's pretty crazy. That's going to get really hot and melt some stuff maybe, and you don't want to catch fire or anything. So it's got some protection stuff in there, max temps, PID stuff, constants for your heated head, more PID stuff. I'm moving through this really quick because I'll get into some of the stuff as I set them up. In-stop is all in here. Here's where you would invert if one of your axes is going the wrong direction. So Z inverts set true, X is true. So that'll switch the direction pulses. Whether they're disabled when they're not being used, how it enables them if that's a reverse polarity on that. Homing direction, which way it goes during homing, all sorts of that's software travel limits, which you would see in a servo drive typically. Which is pretty cool. You can define that. If you don't have a positive end stop and you home to a negative end stop, you can set the distance of where your positive end stop would be, and the software will keep track of that for you and not drive it into a wall or into the end of your limit. So that's pretty nice as well. Bed probing, which I'll get into hopefully later on. That's pretty cool stuff. Homing, more Z homing. Manual homing positions if you define manual home, which means you don't have to have any end stops, which is kind of cool. You can put your printer right in the middle of its bed and just manually home it, and it knows, hey, okay, I got 200 to the left, 200 to the right, 200 front and back, and otherwise don't go further than that. So that's a perfectly valid way of doing it. And I may do some of that. I don't know. We'll see. We'll see. At least in X and Y, I don't know how crazy I'm going to get with the home switches. But here's some preheat constants. So this kind of gets into if you have an LCD display, you can start preheating before you actually run your build, because normally the build temperature is going to be set by a G-code, and so as soon as you run your program it'll start heating, but you may still be moving files or loading plastic or something, so you can get those guys heated up, the bed and the fan speeds and stuff set and going while you're piddling around with other stuff, and then right when you run your program it's just got a tiny bit to adjust. So there's some LCD stuff down here, and some fan stuff. You can do all kinds of stuff. So read through this if you get a chance, especially if you're kind of waiting on parts for your printer. It's a real good thing to catch up with. There's also a configuration advanced.h that has a lot more options in it, and a lot of the stuff I was kind of like, wait, where's all this stuff where you define your second Z motor or your, stuff like that. And all that's in the advanced configuration. All the multiple hot ends and mirrored hot ends and stuff like that you can do in there. So moving on, we're going to go ahead and verify this and see if it likes it. I actually haven't compiled any of this yet, so it is compiling right now. I left a lot of this stuff unset because we're not going to be using a heated anything right now, none of that stuff hooked up, so I'm just trying to get the motor to spin. That's my basic goal here with this video. So I'm going to go ahead and upload that, and hopefully it's recompiling on upload. Really, you just have to hit upload and then it'll compile it and then upload it. But I kind of expected errors, so the things I'd have to tweak, but seems good so far. Still uploading. And the more features you enable, the way they've done this, the more features you enable, the more memory you're going to use. So you got to be pretty memory conscious on these 8-bit microcontrollers. They just don't have that much in storage. It's all flash storage of some sort. So it's non-volatile, which is cool. You don't have to flash it every time you boot it up, but it is pretty limited in memory. So it says it's done uploading. So now what? We're going to need to talk to it over the PC. I assume it has rebooted, and I'll see if I can get connected up. Okay, so I got it powered up with the extra leads here, which are the ones I had originally, and the stepper motor power, or what I've determined to be stepper motor power leads here. This one's still disconnected, which I hope is okay for now. Move the stepper back into frame here. So I am ready to give it a go. Before I do, I've got the ground side of this probe connected to ground of the input here. So on this black wire coming in right there. So what I can do is check. Of course, I've got do this left-handed here. Got 12 volts there. And if I come in and carefully check VREF, I have 6.76. So you multiply that by 2, it'd be about 1.3 amps. So really I probably need to take that back just a smidgen because my motor can't really handle that. I want it right at 0.6 for this driver. So, whoops, it's a little touchy. Back some, it likes to kind of go back. So 0.5, so that would be like just a little bit over 1 amp, which is fine for now. I'm hopefully going to set these digitally later on anyway, so we'll leave it there just to be safe. Okay, so to be fair to PandyCat Devices, I went back and looked at this wiring diagram that they just put up a few days ago. The input 3 here, it actually says connect to main input for single supply. So it shows you bridging these externally if you're going to be using a single power supply. So it's cool because they give you the option to run separate power supplies. What kind of threw me off is that the input 1 here is for the hotbed and the internal 5-volt supply, and it's the biggest of all of them, and it just kind of, I thought that that would be the main supply, which I guess it is for the logic and for one of the biggest current draws, which is the heated bed. So that does make sense. With the stepper motors, I sort of expected this to be a bigger input, but that's fine. Hopefully they can carry the current. And the hot ends is number 2 down here. So if you're going to use all 3 of these things, you need to just connect them all together if you have one power supply. It is nice because I can power my motors off a separate supply if I want. I can run, a computer 12-volt supply and get a smaller 24-volt supply if I want. So I can run kind of a hybrid between 12 and 24. So this is the Pro board. I think they expect you to sort of know what you're doing in that respect, and since this is my first go round on this, it kind of caught me off guard. Alright, so earlier I got the Marlin firmware flashed onto the Azteeg X3 Pro. I had made a mistake, or rather I missed something. You need to come in here if you're going to just try to spin motors without a hot end attached, and define this temp sensor here. So here's the table of temp sensors. 0 is unused, so -1 was suggesting that I was using this, which I'm not. So I'll go ahead and save that, and I will upload that to the Arduino. So while that's going, I will open up Prompter Face, or rather Print Run, which contains a few different programs: Plater, Pronsole, and Prompter Face. I don't actually know what these two do. Slicer also is included, which is the slicing of your STL models to get them down to something that you can print in G-code. So this is what converts the STL to G-code with certain settings and things like that. So Prompter Face is what I'm going to use, at least right now, to interface with the printer. So once completed, which looks like we're done, if you go back to the top, you'll recall that we have set the baud rate to 25, or rather 250 kbps, and normal serial port. So that was COM10 from before, and this defaults to 115.2, so we'll knock this up to 250 rather. So connect, and we are connected here. So you can see some status in this area here. Free memory, some feed rates, things like that, home offsets, PID settings. So it doesn't look like we have any errors, nothing going on. So before I had an error here, that's what fixing the thermocouple setting did, the RTD setting. So now, motors are off right now, so I can enable them with an M17. And hopefully I should be able to jog my motor. Oh, look at him go. We can go by 10 now. And by 100. And so these steps are really arbitrary right now because I haven't set any of my steps per millimeter or any of that sort of thing. So that's basically it. I can move it both directions. That's what I was really hoping to accomplish in this video. The same would go if we went ahead and hooked up the other stuff, the other steppers, and check. Always do a spot check, make sure nothing's getting too hot. This is all good. Probably leave this running for a while and just make sure nothing gets crazy hot. But otherwise, I think we're in pretty good shape. Ready to start wiring some stuff up here pretty soon. Pop the other drivers in there and start running the bigger motors.